in the Department of Science and Technology at Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to take the lecture on the subject name Data Warehousing and Data Mining, and today's session is Hierarchical Clustering. Hierarchical clustering is also known as hierarchical cluster analysis, and it is an algorithm that groups similar objects into groups, which is called as clusters. So the endpoints is a set of cluster here, and in this where each cluster is distinct from each other cluster, and the object within each cluster are broadly similar to each other. So in this there is a required data. You see here this is a hierarchy, and this clustering can be performed with either a distance matrix or raw data. So when raw data is provided, the software will automatically compute a distance matrix in the background. So the distance matrix below you can see here in this 6 objects are there. Okay, so here how hierarchical clustering works. In this hierarchical cluster, you know the meaning of hierarchical and you know the meaning of clustering. So this starts by treating each observation on a separate cluster. Okay, so then it is repeatedly executed the following 2 steps. First step is to identify the 2 clusters that are closest together, and the second one is the merge 2 similar clusters, and this process of course repeatedly continues till the cluster are merged together. So in this diagram you see here, identify the 2 clusters that are closest. So which 2 clusters are? I think these 2 clusters are identified. So merge these 2 clusters, similar clusters like this. This is the after merging. Okay, so then after this we go to the next process, and which is closest to this, then this cluster is closest to this item object is closest to it. So this will merge into this object. So this object is this cluster look like this. Then after it will process which cluster is closest to, means these 2 cluster these 2 objects you see here. So we merge it into one cluster. So here these one cluster. Okay, so the next is the now here see, these 2 are the similar, or you can say closest. So we put it into one cluster. Then after these 2 clusters, and this is the another one. So we merge it into this one. Okay, so then this if we compare, these are the 2 clusters in this object. So these are of course not clear, not closer. So but somehow as compared to these 2 clusters, we again then merge it into this cluster. So finally we get this cluster. So till the final merge, means till the one cluster is not found, we again and again, we continuously repeatedly merge these clusters of these cluster objects, right? So the main output of the hierarchical clustering is a dendrogram, which shows the hierarchical relationships between the clusters. So this is the dendrogram. This is AB, means this is closest, and C here is different. This comes in so in this these 2 are similar, closer. So these put it into this, and this is after combining these 2, or you can merge these 2, then this will might be closest to the D1. So here you can see this is closer to 1, and after merging these 2, this will merge to the C. So here we see this. So this is the dendrogram. Okay, so measure the distance similarity. So in this example above, the distance between the 2 clusters has been computed, which is based on the length of the straight line drawn from the cluster to another. This is the straight line, okay, drawn from the cluster to another. So this is commonly referred to as the Euclidean distance. We measure the distance between 2 clusters by the Euclidean distance. Okay, so many other distance metrics have also been developed. So the another is the linking criteria. After selecting a distance matrix, it is necessary to determine from where distance is computed. Like it can be computed between the 2 more similar parts of the cluster, and the two least similar bits of the cluster. So as with distance matrix, the choice of the linkage criteria should be made based on the theoretical considerations from the domain of the application. So key theoretical issue is what causes variations. Like in archaeology, we expect variations to occur through innovations and natural resources. So working out in two groups of artifacts and a similar may make sense based on identifying the most similar members of the cluster. So where there are no clear theoretical justification, so the method is sensible default. Okay, so in this method, work out which observation of the group which is based on reducing the sum squared. So you see the next is the agglomerating versus divisive algorithm. In this, this works is by sequentially merging similar clusters as shown above in this, and this is known as agglomerated hierarchical cluster, because in theory it can also be done by initially grouping all the observations into one cluster and then successively splitting these clusters. So this is known as divisive hierarchical clustering, and these are rarely done in practice. So that is all about today's session. Thank you. This session powered by digital version 2.0, Jayoti Vidyapeeth Women's University, Jaipur. Hope you are satisfied with my digital session. If you have any query, please mention in comment box. I will resolve it. Thank you.